Hey guys, Mr. Backerberg here. In this video, we're going to take a look at inverse trig functions.
So we're going to take a look at an example right away where we're going to restrict down the domain of a sine function. So if I draw out a sine graph real quick, we end up getting a picture that looks something like this. Now, in order for the inverse to exist, our graph needs to pass the horizontal line test. And because of the way our waves are structured, our graph fails the horizontal line test. So what we're going to have to do is restrict down the domain so that we're only looking at a certain portion of our graph in order to get it to pass the horizontal line test. And how we're going to restrict this down, I'm going to eliminate a whole portion of this graph. And the only piece of the graph that I'm going to leave is the portion between negative pi over 2 and positive pi over 2. If we look along just that chunk of our graph and we run our horizontal line test, that piece of the graph itself will pass the horizontal line test. So we need to restrict the domain of our sine function down to being between negative pi over 2 and positive pi over 2 in order for its inverse to exist. And because all of our trig functions are periodic, meaning that they repeat themselves, we're actually going to have to restrict down all of our trig functions in order for their inverses to exist. So let's dig a little bit deeper into these inverse trig functions. And let's first talk about the inverse sine. So as far as the domain of the inverse sine, we can safely plug in any number between negative 1 and positive 1, including those end values. And the range, when we do that, when we plug in one of those x values, the answers we get back will be angles. And the range is going to be some angle between negative pi over 2 and positive pi over 2. Now, if we talk about the inverse cosine, the domain is very similar from negative 1 to positive 1, but the range, those angles that we're going to get back as answers, are slightly different. So the range on an inverse cosine is some angle between 0 and pi. As far as the inverse tangent, for the inverse tangent, we can safely plug in any number that we want, but as far as those range angle answers that we're going to get, it's going to be some angle between negative pi over 2 and positive pi over 2. Now we've also got inverses for our reciprocal functions as well. So looking at the inverse cosecant, we can safely plug in any x value such that its absolute value is some number that's greater than or equal to 1. And the angle answers that we'll get will be somewhere between 0 and pi, but it can't be pi over 2. That angle is not included in the range. Similarly, for the inverse secant, as far as the domain, the absolute value of the x values that we're plugging in have to be greater than or equal to 1. The angle answers that we're going to get back are going to be somewhere between negative pi over 2 and positive pi over 2, but 0 is not included. And then lastly, our inverse cotangent. We can safely plug in any x value that we want. And as far as those angle answers that we're going to get back, those are y values that are between 0 and pi. So here's the same information, but presented visually instead. So this is a graph of y equals the inverse sine of x. We can see that the domain, the x values, are between negative 1 and positive 1, and the y value range is between negative pi over 2 and positive pi over 2. For the inverse cosine, our domain is between negative 1 and positive 1, with a range between 0 and pi. And then for our inverse tangent, these lines extend to the left and to the right forever and ever, so the domain is from negative infinity to positive infinity, with a range between negative pi over 2 and positive pi over 2. For our inverse cosecant, we've got a domain that includes x values that are less than or equal to negative 1, or greater than or equal to positive 1, but there's nothing happening in between negative 1 and positive 1. As far as the range, we've got y values that are between negative pi over 2 and positive pi over 2, but not including 0. For the inverse secant, we've got a domain of x values that are less than or equal to negative 1 and x values that are greater than or equal to 1. Again, nothing happening in between there, with a range between 0 and pi, but not including pi over 2. And lastly, our inverse cotangent. Again, these lines extend to the left forever and ever and ever, so the domain is between negative infinity and positive infinity with a range between 0 and pi. So again, this is just a visualization of that information that we just looked at from that table. Taking a look at this example, we're going to find the measure of the inverse cosine of negative 0.5 in both degrees and radians. And I'm going to use my calculator to help me out with this. Now I'm going to do this in radians first because my calculator is already in radian mode. So to do the inverse cosine, right above the cosine button, there's the inverse cosine. So I'm going to go second cosine, and we're supposed to evaluate negative 0.5. And I'll close up my parentheses, hit enter, and it tells me that I get 2.094395102. Now that happens to be the angle 2 pi over 3. Now I can also tell my calculator to give me a degree answer as well by switching what mode we're in. So if I change my mode into degree mode and then do that exact same thing, it's going to give me an answer of 120 degrees. And 120 degrees in radians is 2 pi over 3. So those two things match up. Taking a look at this example, we're going to be solving some equations for x. So the first equation that we're given is the sine of x equals 0.7. And we're looking for x values that are between 0 and 2 pi. Now before I get too far into this, I'm going to draw a picture to help me understand what's happening in here. As far as the unit circle goes, when we're evaluating a sine, we're looking for a y value on an ordered pair. So we're looking for a y value of 0.7. And that's actually going to happen two places on our circle. I'm just going to approximate one of them to be about right here. I'm going to say that this ordered pair has a y value of 0.7. And I'm going to call this angle theta. Well, directly across from it in the second quadrant, this point right here is going to have the exact same y value. Now there's a relationship between this angle theta and this other angle that would take us over here into the second quadrant. And what's actually happening in here is this angle theta that I have drawn out in red and this angle over here on the left-hand side, those angles are exactly the same size. So once I know how big this angle theta is, I'm going to be able to figure out how big this second quadrant angle is as well. So now let's go back to our equation. If I want to solve to get x alone, I'm going to have to move this sign over to the other side. And to move something across the equal sign, we always have to use an inverse operation. So to take this sign and move it over to the opposite side, I need to do the inverse of sine. So we get x equals the inverse sine of 0.7. Now if I type that into my calculator in radian mode, I'm going to go to 4 decimals. I get 0.7754. So that tells me this first angle theta over here. But I still need to find the measure of this other angle. Now using what we know about the unit circle, if I were to go all the way across, that's an angle of pi. And what's happening in here is we're backing this angle up by that theta distance. So if I take pi and subtract off that theta answer that I just got, that's going to give me the size of this second angle that I have illustrated in green. So if I take pi and subtract 0.7754, I'm going to get an answer of 2.3662 if I round off to 4 decimal places. So these are going to be my two answers on that interval from 0 to 2 pi. Our first one was that 0.7754, and my second one, when I did pi minus that answer, we got 2.3662. In this last example here, we're going to solve the equation tangent of x equals negative 2 for all x values between negative infinity and positive infinity. Now, if we do something similar to what we did earlier, if I want to isolate this x, to move that tangent over to the other side, I have to use an inverse tangent. So I'm going to get x equals the inverse tangent of negative 2. And then if I type that into my calculator, again in radian mode, I get negative 1.1071 if I round off to 4 decimal places. Now the thing about a tangent is that it's periodic every pi along our unit circle. So if we're talking about every single x value between negative infinity and positive infinity, there's more angles that we need to account for here. So we need to account for any potential multiples of pi that we could be adding to this answer that we just got. So in order to do so, on the end of this answer, I'm going to put plus k pi. And that just means that we're accounting for any extra multiples of pi that could take us either in the negative direction or in the positive direction for that x value. And again, that's because the tangent is periodic with a period of pi. That's going to be it for this video. Thanks for watching.